Welcome to the deep dive. We've had a lot of you share sources about certifying IoT devices.
Yeah, it's a hot topic.
It really is. And let's be honest, looking at all this info can feel like, well, like trying to figure out completely new plumbing.
Yeah, that's a good way to put it.
So our goal today is basically to give everyone the toolkit, the essentials, to grasp what really matters here.
Exactly. Think of IoT device certification as like the quality control check for the connected world.
Okay.
It's all about making sure these devices, play well together according to rules set by industry, regulators, and the networks themselves.
Right, the actual networks they run on.
And it's specific to where they'll actually be used geographically.
Okay, so it's not just about getting a sticker. It's about making sure your, smart toaster doesn't accidentally crash the local mobile network.
Well, maybe not the toaster, but yeah, that's the underlying concern.
Okay.
Seriously, though, poorly designed devices or ones that haven't been certified, they can cause a whole mess of problems.
Like what kind of issues are we talking?
Subpar performance, for starters, devices just not working reliably. But worse, they can cause actual network interference, even potentially network outages in some cases.
Wow. Okay. So pretty serious.
Definitely. Which is why, in a lot of places, certification isn't just a nice to have. It's often mandatory before you can even sell or deploy these things.
A fundamental hurdle then, really.
Yeah.
Now, looking through these sources also really jumps out that navigating this whole certification thing, it seems like a real challenge.
Oh, totally.
Time-consuming, expensive maybe, prone to delays.
You've hit the nail on the head. It can be a long process, and it definitely comes with costs. Delays are, well, pretty common.
Right.
And if your device fails, you could be looking at major redesigns. That throws your whole timeline, your budget, completely off track.
Ouch. Okay.
So yeah, part of what we want to do today is shed some light on the different types of certification and, point out some of those potential roadblocks.
Good plan. So where do we start trying to unravel this? The sources seem to break it down into a few main areas.
Yeah, let's start with the foundation, which is regulatory certification.
Okay, regulatory government stuff.
Exactly. Mandates set by governments in different countries. They cover things like basic electrical safety.
Making sure it doesn't catch fire.
Pretty much. Also, RF emissions, how much radio energy it puts out. Electromagnetic compatibility, or EMC.
That's the not messing with your neighbor's TV part.
That's the one. And even environmental factors, like what materials are used and how it's disposed of.
So it's not like one global approved stamp then?
Not at all.
Yeah.
If you plan to sell your device internationally, say in Europe and the US and maybe Asia...
You need different approvals for each?
Very likely, yes. Each market often has its own specific set of rules and standards you need to meet.
Makes sense. Different places, different concerns.
Yeah.
The sources actually list a few examples.
They do.
Like CCC in China. China compulsory certification.
Yep, that's a big one for accessing the Chinese market. Covers a huge range of products, IoT included. Often requires testing within China, too.
Okay. And then for Europe, there's the EMC directive
Right.
and something called the RED directive.
Right. EMC is about limiting that unwanted electromagnetic noise. RAD, the Radio Equipment Directive, that focuses more on the efficient and safe use of the radio spectrum itself.
Then the U.S. has FCC Part 15B.
Correct. That's mainly focused on unintentional radio emissions from digital devices. Things that aren't supposed to be transmitting radio waves, but might inadvertently create some noise.
So if you're planning a global product launch, that checklist could get pretty long.
It really could, and it's not static either.
Oh.
The sources point out there's a growing trend towards regulations covering newer areas, too. Things like data privacy, device security, reliability, even traceability through the supply chain.
So compliance is a moving target.
You could say that. Staying current is definitely part of the challenge.
Okay, so that's the regulatory layer, the government mandates. What's next?
Next up is the telecoms industry certification. This is crucial for anything connecting via mobile networks, cellular IoT. There are two main schemes mentioned prominently, both based on the 3GPP standards.
The 3GPP, that's the big global group defining mobile tech standards, right?
Yeah.
Like 4G, 5G.
Exactly. So these schemes look at compliance with those standards, plus things like how the SIM card works in the device and antenna performance. Very important.
And those two main schemes are GCF and PTCRB.
Spot on. Let's take GCF first. Global Certification Form.
Okay.
The sources describe it as a worldwide scheme, and technically it's voluntary.
Voluntary, so you don't have to do it.
Well, it uses a system of self-declaration, but there's quality assurance built in. And here's the key thing. Many major network operators are GCF members.
Ah.
And they might actually block devices from their networks if they aren't GCF certified.
So voluntary, but kind of not really, if you want your device to actually connect anywhere useful?
Pretty much. It acts as a strong signal that your device meets essential industry benchmarks for interoperability. It's like an unofficial passport for many networks.
Got it. So GCF is global-ish, voluntary-ish? What about the other one, PTCRB?
Right, PTCRB. That stands for PCS Type Certification Review Board. This one is mainly used in North America.
U.S. and Canada.
Primarily, yes.
Yeah.
And unlike GCF's voluntary nature, PTCRB certification is often mandatory if you want your device to operate on the networks of PTCRB members.
Okay, so no wiggle room there if North America is your market.
Generally, no. If you want to connect to major carriers there, PTCRB is usually a must-have.
And how does that work? Testing?
Yes, it involves quite rigorous testing, and it has to be done at specific labs that are approved, accredited by PTCRB.
Okay.
And same deal as with GCF. Really, if you don't have the certification, you run a very high risk of being blocked from those networks.
It really highlights how much power the mobile operators have.
They certainly control access to their infrastructure, and that actually leads us nicely into the next layer of certification.
Where's more?
Oh, yes. Operator certification, specific to individual carriers.
You mean like Verizon or AT&T or Vodafone having their own tests on top of GCF or PTCRB?
Precisely. Even if a device has those broader industry certifications, an individual mobile network operator, an MNO, can still impose its own requirements.
Why, though? What's their main concern?
Protecting their network performance, simple as that. They need to ensure that any device connecting doesn't negatively impact the service for all their other customers.
Makes sense.
Yeah.
One bad device shouldn't ruin it for everyone.
Exactly. And they have the ability, and frankly, they will block devices they think are problematic or might cause harm.
And the sources mention something interesting here, that the MNOs with the toughest certification programs often have the best networks.
That's a common observation, yeah. Those operators invest heavily in ensuring everything on their network works flawlessly.
Which would be attractive if your IoT application is, like, business critical.
Absolutely. Think healthcare monitoring, industrial controls, logistics tracking.
Well,
you need reliability.
Right.
But as the material points out, getting onto those high-performance networks often means you need to get specific device certification directly from that operator beforehand.
An extra hoop to jump through,
Yeah.
but potentially worth it for the network quality.
That's the trade-off.
Do the sources name any operators with these kinds of programs?
Yes. Verizon and Deutsche Telekom are mentioned specifically as examples of operators with their own quite detailed certification schemes.
Okay.
And the goal of these programs is really to minimize connectivity problems and prevent any harm either to the network itself or to other users.
So what do they test for? Is it just repeating the GCF, PTCRB stuff?
Not entirely. There's overlap, sure, but operated tests often focus very specifically on how the device interoperates with their unique network configuration, their specific parameters.
The nitty-gritty details of their setup.
Exactly. And they often dig deeper into real-world performance. They'll test things like radio sensitivity, how well it picks up a weak signal.
Okay.
Also, how often it drops connections, how smoothly it hands over between cell towers if it's moving, actual data speeds achieved on their network, and even battery life.
Battery life.
Yeah.
How does the network affect that?
Network signaling, how efficiently the device communicates, power-saving modes. It all impacts battery drain. Operators want to ensure devices behave efficiently on their network.
So it's much more about proving it works well in their specific live environment.
Precisely. Less theoretical, more practical, and particularly with newer tech like LTE-M, NB-IoT, 5G, these operator tests ensure devices are properly tuned for those network features.
Okay.
They might also cover things like remote device onboarding using eSIMs or UICCs, the embedded and reprogrammable SIMs, how smoothly that process works on their platform.
Wow. Okay. It's definitely a layered cake, this certification business. Regulatory, then industry, then operator specific.
Right, you're getting the picture. And believe it or not, there's potentially another layer.
Seriously. What
Other industry-specific certifications.
Like for particular verticals?
Exactly. The sources mention automotive and medical as key examples.
Ah, okay. That makes intuitive sense.
IoT devices going into cars or used in medical settings often face much more demanding requirements. So they might need additional certifications specific to those industries.
What kind of things would those cover?
Often a heavy focus on end-user safety, naturally, but also specific operational demands, things like surviving extreme temperatures or resisting heavy vibration, stuff you wouldn't worry about for a smart home device.
Right. A sensor in an engine bay has a tougher life than one on a bookshelf.
Exactly. So you add all these potential layers up: regulatory, telecoms industry, operator, maybe even vertical industry specific.
And it becomes clear why the sources say this is complex, costly, and time-consuming.
It absolutely can be. It can genuinely be a barrier for some companies, especially smaller ones, trying to get their IoT product to market.
And even if some certs are technically optional, like maybe some aspects of GCF,
Right.
the sources still suggest that meeting these standards is generally a good idea for trust and security.
Definitely.